Mr. Ahmed here for lesson 1.6 in geometry. Our essential question today is how do we use specific angle pairs? Now I kind of filled in a little bit of this ahead of time just because the naming of these is fairly straightforward, and a couple of these terms you've probably seen before. So the first term is complementary angles, and the complementary angles are two angles, all right, just two, whose measures add up to 90 degrees. Now, a couple ways you could see them. You could see them with one right angle and something splitting them into two. So in this case, angle 1 and angle 2 have to add up to 90 degrees based off the angle addition postulate. So angle 1 and angle 2 are complementary, abbreviated complementary with COMP. And in a similar manner, angle A and B, if A is 20 and B is 70, those two would add up to 90, so they are also complementary. Supplementary angles are two angles whose measures add up to 180 degrees, okay? Another way you might hear that is one angle is the supplement of another. And in the diagram, the first example, you're gonna see these come up quite a bit. We have two angles right next to each other that make a line. We're going to define that as well, but these two have to be supplementary because we can assume that's a line. It looks like a line, so it's 180 degrees. So angle 3 and angle 4 are supplementary. They are supplements of each other. They add up to 180 degrees. And C and D, 115 plus 65 is 180. So C and D are also supplementary. Our next term is adjacent angles. Adjacent means right next to. Two angles are adjacent if they share a vertex and a side. So in this diagram, I highlighted angle ABD in green and angle DBC in yellow. Those two are adjacent because they have a common vertex B and the common side BD. So they're right next to one another. They are adjacent. The linear pair, this is the big bad boy. We use this one a ton. Two angles that are adjacent and supplementary make a linear pair. Linear pairs make a line. Two angles that make a line. So in this diagram, angle 1 and angle 2 are adjacent. They share a vertex and a side, and they also form a line. So angle 1 and 2 are a linear pair, and linear pairs are always supplementary. So the linear pairs have to add up to 180 because it's a line. And the last one, vertical angles. This is another big one. Okay, we'll see these all year. I'm kind of cheating and telling you that they're congruent now. We aren't going to use that much, but in the future it's vital. So vertical angles make an X. They make an X, okay? So they're across from each other. And in this diagram, angle 4 and 5, they are across from each other. They make an X. And in a similar manner, angle 3 and angle 6, they're across from each other. They make an X. Vertical angles are also congruent. They have the same measure. So those are our angle pair relationships. Got to memorize these terms. All of these are vital. They will be used all year. So it's something you really need to just memorize, lock it in. All right, when we set up our angle pair problems, I am going to set it up using 3 steps. All right, first thing I'm going to identify is what type of angles are they? Then what do I know about them? Then I'll write the equation and then I will solve. So, first one says find the value of x and PQS. So PQS, I'm looking for this one, the little one up here. So I see this box. That box tells me it's a 90-degree angle, and there's two angles inside. So what do I know about those two angles? They are complementary. So they are complementary angles. You do not need to write down this process every time that you set up a problem. You should just think to yourself, okay, they're complementary. Step 2, what do I know if they're complementary? They add up to 90. So now for me to set up my equation, angle PQS, 3x, plus SQR, which is 8x plus 2, has to equal 90. So I'm going to highlight this as well, just so it's a little bit clearer. So when I looked at the first angle, angle PQS right here, that one is 3x. And the other angle, SQR, down at the bottom, highlighting in yellow, this one, together, they make the box. So they have to add up to 90 degrees. Complementaries add up to 90. Now we can solve the equation. Like terms, 11x plus 2 equals 90. 11x equals 88, and x would have to equal 8. So we found x. We also have to find PQS, so substitute it back into PQS, which is the green one. So the measure of angle PQS is equal to 3 times 8, which is 24 degrees. And then finding the yellow angle would be pretty easy as well. I could just take 90 minus 24 and I would know SQR. Didn't have to, just thought I'd point that out. Next one, looking at the diagram. What type of angles are they? I see a line. Linear pair, 2 angles, make a line. Linear pair. What do I know about linear pairs? They add up to 180 degrees. So, setting up my equation, the first angle, I'm going to call that angle 1 and angle 2. Angle 1 plus 2, little 1 plus the big one, makes the line. They add up to 180. You have to look for lines and diagrams. You will have to see those all year. So, x plus 2 plus 5x plus 10 is equal to 180 degrees. Now for me to solve, combine like terms, 6x plus 12 equals 180. When I subtract the 12, 180 minus 12 is 168. Divide 6, and we get 28. And we only had to find x, so I do not need to plug that back in, but if it asks me to find an angle, you might have to substitute it back in. Next two are pretty straightforward, just a little different wording. If angle 1 is a complement of 2, that means angle 1 plus angle 2 has to equal 90. So if 1 is a complement of 2, the measure of angle 1 plus the measure of angle 2 has to equal 90 degrees. It says angle 1, 62, so 62 plus measure angle 2 equals 90. When you subtract 62 from both sides, the measure of angle 2 is 28 degrees. Now you could have obviously just taken 90 minus 62. I just wrote out the equation so it was clear. Other word for supplement or supplementary is supplement. So if 3 is a supplement of 4, that means that the measure of angle 3 plus measure angle 4 has to equal 180. Supplementaries add up to 180. It says angle 4 is 47, so measure angle 3 plus 47 equals 180. Subtract 47 from both sides, and the measure of angle 3 is equal to 133 degrees. So we have found our solution. You will see a few like that as well. On to a couple more challenging ones. A little bit tougher here. It says, find the measure of angle FBD. This notation here got a little bit off on us. The if was supposed to be on the same line. But finding the measure if FBD and DBE are complementary. So that means they add up to 90. So let's see here. FBD, I'm going to say 90 degrees. So here's F, B, and D. And D to B to E, that's the other one. There's my two angles. And it says FBD is twice DBE. So FBD is bigger than DBE. I don't know either one of them. So if I let the small one be X, the other one has to be twice that, which is 2X. Together, these two have to add up to 90 because they're complementary. So 2X plus X equals 90. 3x equals 90, and x is equal to 30. And the angle we were supposed to find was FBD, so I have to plug 30 back in for FBD. So FBD is 60. Found it. All right, one more difficult one. It says, find angle A if A and B are supplementary. So supplementary, I usually just draw a line, linear pair. Here's my first one. All right, so let's call this one, actually I probably shouldn't have drawn a linear pair since it just called it A and B, but we will make it happen. We'll call this one angle A and this one over here angle B. Don't really like my notation on that, but it'll work. So the first step that we have, angle A is 5 less than 4 times B. So it actually turns out angle A is smaller. When I drew it, I have angle A is bigger. That's okay. My diagrams are not always going to be to scale. All right? I mean, when I draw out a picture, I'm not going to take out a protractor, a ruler, etc., and just measure everything to make sure it's exact. I just drew it out. I mean, I just have to go off the diagrams. Sometimes a picture will be wrong. So A is 5 less than 4 times B. I don't know what B is. We're calling B X. Okay? Angle B is X. And if A is 5 less than 4 times X, this one's a little bit tricky. I can't take 5 minus 4X. That's the wrong way. It's 5 less than 4 times B. So I have to take 4X less 5. That's my notation for angle A. Angle A is 5 less than 4 times whatever B was. B was X. It's about as tough a one as you're going to see. Together, these two add up to 180. So 4X minus 5 plus X equals 180. Now we just have to solve. 4X plus X is 5X minus 5 equals 180. 5X equals 185. And 185 divided by 5 is 37. So X is 37. And we're supposed to find angle A. So I have to put that back in. So using my calculator for this, 4 times 37 is 148. Plug it back in. 4 times 37 minus 5. And 148 minus 5 is 143. So the measure of angle A is 143 degrees. All right. The last ones are a little easier. Identify the linear pairs that include angle 4. So for a linear pair, we have to have 2 angles that make a line. So when I look at this, angle 4 is here. The one it makes a line with is angle 1. So angle 4 and angle 1 are a linear pair. And angle 4 and angle 5 are a linear pair. Make a line. All right, identify a pair of vertical angles. So vertical angles are across from each other. They make an X. Now, angle 4 here, there is an angle across from it. It's angle 2, but if I trace it, that does not quite make an X. So 4 and 2 are not vertical angles. Angle 1 is straight across from angle 5. If I trace those two, they do make an X. So angle 1 and 5 are vertical angles. 3 is not a vertical angle with 4 either. When I try and trace angle 3 and angle 4, we don't quite get our X. Okay, so you have to trace it and get an X. And lastly, what would be the measure if I took the sum of angles 1, 2, and 3? So if I look at angle 1 plus angle 2 plus angle 3, I see a line. So they would have to add up to 180 degrees. They are not a linear pair because there's more than 2. There are 3. That's all we got for today, and that is actually it for the notes for Chapter 1. Have a good one.